Okay, so welcome everybody. I am Tom Lauwers. I am the founder and CEO of BirdBrain Technologies, and today I want to talk about artificial intelligence and machine learning and some libraries that were partially developed here to use image recognition in Snap. But before I get into our presentation, I also want to introduce Jen Norton. Jen, do you want to unmute and introduce yourself?
Hi, everyone. I'm the product coach for BirdBrain Technologies. I'm a former math and computer science teacher in Georgia, United States. So glad to be here.
Yeah, so Jen is currently in the Atlanta area, and I'm currently in Belgium. So I'm actually on Central European time or Western European time. So I wanted to be absolutely sure that I had the time right for this presentation. All right, so I'm going to share my screen and get our presentation started. Go. Slideshow. All right, give me a thumbs up if you can see it. Okay, cool. All right, so here's the link to the slides, and there are a few embedded links within these slides. And so there will be a hands-on portion in about 15 or 20 minutes, maybe sooner. And so if you will want to follow along with the hands-on portion, you'll want to have these slides open somewhere. So I'm going to start briefly by defining artificial intelligence and machine learning, because there's a lot of use of the term artificial intelligence in, the kind of society at large, but also in terms of education, right? Artificial intelligence is a big buzzword right now. And what we're actually doing today is more properly thought of as machine learning. And so I want to draw distinctions between the two of those terms. And then we're going to talk through training a model with Google Teachable Machine and then integrating that model into Snap. So that'll be I'll do that first. And then anybody who wants to do it, you'll have 5 or 10 minutes to train a model and then a little more time also to integrate it into Snap. So it's definitely meant for audience participation and for all of you to kind of do that part at home as well. Okay, so let's talk about artificial intelligence. So, I was trying to figure out the best way to explain this in lay terms, and the broadest definition that I found, and I like broad definitions, I have a very broad definition of robotics also, is any system that allows a machine to make a decision. And so that can be, obviously leads people to think, well, okay, so does that mean that like my home thermostat is artificially intelligent because it detects temperature and then turns on the furnace? And the answer is it depends on how far back in time you go. And that's the problem with artificial intelligence, is that we keep redefining it based on our notion of human intelligence. And so one quote that I like is, intelligence is whatever machines haven't done yet. And basically saying that human beings want to define as intelligent whatever human beings can do exclusively. And so that's why kind of the benchmark of what counts as artificial intelligence keeps changing. And one way I like to think about that is with checkers and chess and Go, right? So in the 1950s or 60s, you had computer programs that could beat people at checkers. Then in the 1980s and especially into the 1990s, you had computers that got better and better at chess until they beat the best human players at chess. And then in 2015, we had an artificial intelligence program that beat players at Go. And so the benchmark there kept moving in terms of what is intelligence. People kept saying, well, checkers is kind of dumb. And then with chess, it's like, well, chess is very deterministic and the computer is just crunching through every possible, board position to get the right answer or to win. But with Go, you can't do that. And so with Go, they developed a machine learning model that basically developed better heuristics or better strategies to beat people at Go. But then, the question becomes, well, is that really general purpose? Can it beat you at poker also? Can it beat you at different types of games, including games of chance? And so there is this little bit of redefinition going on. So in terms of what we are actually going to do today, I like to talk about it as machine learning. And machine learning is a specific type of artificial intelligence that uses large amounts of data to make models that then make predictions. So the predictions are basically based on, if you train the model on a lot of data and then you show it a new piece of data, it tries to say which of the things that you showed it before that thing is. And it seems to be responsible for most of the major breakthroughs in AI in the last decade, at least. And we use it all the time at this point. When you get a recommendation of what to write next, when you do speech to text, when you do Google Translate, when you're recognizing faces, all of those things are common modern applications of machine learning models. This is where things get interesting, in my opinion. So I've seen some machine learning models that are doing fairly amazing work. So this is a writing sample from an AI model or machine learning model called GPT-3. And with GPT-3, you can give it prompts. So you can give it a one-sentence prompt, and it'll write an essay or a paragraph based on that. You can give it a title, and it'll suggest better titles, and then it'll write kind of an essay about it. So the prompt here was write a love letter written by a toaster, and I'm not going to read all of it to you in the interest of time, but it's pretty funny, and I suggest reading it later. We've seen AI written essays are now getting an average of a C on college writing assignments. So this is GPT-3 basically taking the prompt of an essay writing assignment at the college level, and that being submitted along with human written essays. And you can see the grades they're not great, but they're not terrible. It's like it's pretty interesting where it's going. You've got AlphaCode placing in the median in competitive coding competitions. Now these are generally small bits of code, like they're writing short algorithms, but it's still interesting that it can do this. And there's a commercial product as of the last 6 months or so. I think it's called Sidekick. It's through GitHub, where as a professional software developer, you can now use this to help you write your code. So you can say, hey, write me a sorting algorithm while I do kind of the higher level software architecture. And then, I don't know how many of you have seen like DALL-E 2. DALL-E 2 is a text to image model that will ingest, a prompt again, like a painting of a fox sitting in a field, sunrise in the style of Claude Monet, and then it produces fairly interesting art. It's not always great, but it's definitely interesting, and it's not, it's recognizably a fox, and it's recognizably like Monet's style. So I like to just look at their Instagram page, and I think there's a new model from Google called Imagen, which actually seems to do even better in some ways, especially with digital photography, or not real photography, but photorealistic images. So, it's interesting, and it leads, of course, to both questions about what do humans still do, and also what should we be telling our students about this, and how should we be introducing this to them, right? So in my view, and there are many views on this, all the way to humans are going to be completely obsolete to, this isn't actually a big deal, kind of that's the spectrum. But in my view, you still have humans that need to train models. You still need them to provide good prompts. The AI is not just self-generating the creative idea. You definitely need editing and approving and ensuring that there is no bias in whatever gets created. You need some synthesis. And I think of the future creative work in many of these industries, which are getting these AI models or machine learning models, as you sort of get a team of AI helpers, right? So instead of you are a graphic designer and you're tasked to make an advertising campaign or whatever it is, or you can create lots of different designs very, very quickly, or you can get inspired by lots of AI generated designs and then take the best ones, merge them. So really speeding up your creative process. I think that's where this probably goes, is in that sense, at least for the near to medium term future. But to do a lot of the above requires understanding how machine learning works. And that doesn't necessarily mean getting into like the Bayesian statistics at the bottom of the neural network or anything like that, but it does mean understanding how the models get trained, what their limitations are, kind of getting that sort of intuitive understanding of like, this is a tool, how do I use this tool? Well, hopefully I've used similar tools in the past, right? Like really getting it, not just theoretically, but practically in the sense of having used it. Yeah, so that's my introduction to AI and machine learning. Copilot, thanks, Dan. So the not Sidekick, but Copilot is the name of the code writing AI. Okay, so to move on into the kind of hands-on portion of the presentation. So we, or BirdBrain Technologies, has been using some code developed by Ken Kahn and by our former director of engineering, Bambi Brewer, to allow us to take machine learning models that are created by students through Google Teachable Machine, import them into Snap, and then use them to control robots. So here's kind of a quick video demonstrating that. And so this is Bambi controlling the Finch robot by wearing different masks, essentially. So as she puts on Darth Vader, the LEDs turn red. It's actually, the sound might be a little hard to hear, but it's doing the Imperial Death March. And then as she shows it like Grogu or Baby Yoda, it's doing it turns green and it's dancing around a little bit. And so basically what this is turning for our purposes, for robotics purposes, is it's making these machine learning models into sensors. So they're like it's like a new sensor that we can now use with our robots, which is great. But it doesn't have to actually be limited to using it with robotics. And so this presentation, we're just going to focus on using the model, training the model, and then just using it in a generic Snap project. And so that way, you know, even if you don't have robots or any physical computing devices, you can still use these as interesting sensors going forward. All right, so as I said, we developed several different activities using Teachable Machine. So Teachable Machine is a tool developed by Google that lets you train different machine learning models, one for identifying objects, one for identifying audio, and one for identifying pose. So that's like how you hold think of it like skeleton tracking. If you use like the Microsoft Kinect from a long time ago, that's pose recognition. And so we have these activities on our website for using it with Finch and also for using it with Hummingbird. As I mentioned, Ken, and I think I saw Ken on the list actually. Let's see.
Yeah, I'm here.
Yep. Yeah, thanks, Ken. So, so Ken developed a lot of the kind of initial code that we ended up using with these extensions. And he has several talks about different efforts for using machine learning in Snap that I noticed in the Snap conference program. And since this is the first session, you can go to all of Ken's talks later on. So they're linked here. And then Bambi Brewer took that code and turned it into the kind of projects that we ended up that we use and that we'll share here. And so Bambi is not presenting on AI, but she is at the Snap conference. And so you can see her presentation about the work that she's currently doing, and that's linked there. So I just wanted to give credit where it's due. I mostly wrote up some of the activities, the Hummingbird activities. Bambi actually wrote up the Finch activities. And I did not do most of the code development here, or really, I would say none of the code development. So yeah, so let's talk about how this works. So inside Google Teachable Machine, we're going to make a machine learning model, and inside their web interface, which is very easy to use and user-friendly, will basically be creating training data. So training data being like different objects. So I'm going to hold up several objects to the screen and kind of show it to the model as it's being trained. Or I'm going to generate training data using these different objects. Then I'm going to hit a train button, which will use some essentially, I mean, we'll talk about it a little bit later, but use a lot of math basically to create the model. And then there is a little testing thing within Google Teachable Machine, so I'll be able to test if my model is working. And then once we're happy with it, we're going to be able to import it and use it inside of Snap. So, so I'll do this first, and then if you want to follow along, you can. So I think my suggestion is that, yeah, I'll show you how to train it. And then then I'll give you some time to kind of train your own model, and you'll be able to follow along either with the steps at this link, or the steps are also kind of here. But watch me do it first. It's probably easier to just see. Okay, so like I said, I have three objects. So I'm going to train based on this, I think it's a My Little Pony, this little guy, and the Hulk. So let's start with the Hulk. So to train the Hulk, first I like to name my classes so that I know what, when I import it into Snap, it's useful to know which thing is which. And I'm going to try to kind of get out of the shot here. And I'm going to go to webcam. Now this is, okay, my Zoom webcam is still running. I have two webcams attached to this computer. I've noticed that if you only have one, you may not be able to do both Zoom and Teachable Machine. So I would just turn off your webcam in Zoom before you run Teachable Machine, because that's more important, I guess. So here's the Hulk, and I want to make something like 200 to 400 samples of the Hulk in many different orientations. So this actually goes pretty fast. I'm going to hold to record, and notice I'm making something like 10 samples per second. And so I'm going to hold him in different orientations, different distances. Basically, the more orientations, distances, etc., that you get, generally, the more robust your model will be. All right, so now I'm going to do the same thing with the pony. All right, so this is a smaller object, but I'll hold and record it. It's good to kind of show different orientations. It would be great if I could avoid having my arm in here, but so we're not making the world's best machine learning model here. And one of the fun things about this is like seeing where it breaks. Like the background, my background has a big red thing. So we'll see if that has any impact when I'm training a red object. I don't even know what this is, but it's cute. Gremlin. So train this. So, all right. And now I like to have a fourth class with nothing in it. And this way I can kind of get it to be somewhat robust against the background. And I may even like put my hand and shoulder, because I was in there a few times, just to like give it some sense of what is not important to pay attention to. All right, so once I have my 4 kind of classes trained, I'll hit train model. This is where the browser will often complain that it is waiting on the page to do something. And it'll also tell you don't move away from this page. So you want to leave the page open while it's churning through this. So this is normal, the page unresponsive error. Just ignore that if it happens to you. And then yeah, don't click away from the page while it's training. So training, depending on your computer, will take, you know, up to a couple minutes, or depending on how much data you've added also. Okay. Just have to twiddle our thumbs for another, I don't know, 20 seconds or so here, probably, maybe 30 seconds.
You can click on advanced and kind of show the progress as it's doing.
Oh, thank you. Yeah.
Under the hood.
Ooh, that's cool.
Yeah, here comes.
Yeah. Yeah, so you can calculate accuracy per class and fusion matrix. I haven't actually played around with this, with the advanced stuff. Okay. All right, so now you can see it's predicting me. So, you know, none of the training data actually had my face in it. And so you can see that it's completely confused. Sometimes it thinks I'm the Hulk, sometimes a pony, sometimes nothing. But if I go away, it's very sure that this is nothing. And even, you know, my hand in it, mostly, you know, it gets recognized. So if I do this, the gremlin seems to be pretty accurate when I hold it here, but now it's, well, okay, it's doing all right. But every now and then you can see that it glitches. So sometimes it thinks it's a pony, and like out here when it's really small, it thinks that's nothing. So that's interesting. But for the most part, I can get my classes to be recognized with near 100% accuracy in most of the positions that I trained them in, you know, so that's logical. Like if it didn't see something too far away, like, or if it didn't, you know, it's mostly working off of what it knows, right? The Hulk seems to be very easy to detect because probably the Hulk is quite large. So, all right, so now we have our trained model. So I'd like to stop now and have you all find 3 objects and train a model, and I'll give you guys like 10 minutes to do this. So again, I want to share, like, you know, I have the model training steps here. You just saw me do it. And then also on this page, bottom of this slide, you know, these are kind of your step-by-step instructions also. So you can get all the way to, well, we'll get to uploading the model and importing it into Snap, but we'll get there in a little bit. So just try to get to the point where I am, basically where the model is trained and recognizing different objects properly. And if you have questions in the next 5 to 10 minutes while you're doing this, or if something's not working, feel free to unmute or put it into the chat. We can help out. So just a couple tips also while we wait. If you have image samples that you don't like, you can delete them out of the model just by hovering over the image and just hitting delete. You will have to retrain the model every time you edit one of these classes, so including even deleting one picture. Same thing with a whole class. Like if you feel like you didn't do a good job training the first time, you can just click on the 3 dots in the class, and you can click delete class and delete the whole thing, and then, you know, create a new class with it. So there's ways to kind of change it or edit it if you trained it and you're testing it and you're like, this isn't really working the way I want. You know, so I could add like with me in the model, obviously the model goes crazy in my case. So like Hulk and Pony and whatever, it doesn't seem to know. So I could add a class that's just me, for example, and then probably it would recognize as a separate kind of object. And then if you want to save these models, you can save them to a Google Drive. That's by using the 3 horizontal bars to the right, to the left of Teachable Machine, or you can download the project. So you can actually just download it as a file. I've noticed when you open it again, you do have to retrain it and re-export it to the cloud. But that way, at least you have it kind of ready if you want to use it again. So just a few things, like a few interesting things around the interface. And then I'll go to under the hood and take a look at that while you guys are still working on this. Alrighty, so the next step is to get the model to work inside a Snap project. And the first thing we need to do for that is to export our model. So we click Export Model, and then you don't need to change any of these settings. You basically do want the shareable link because that's what we'll use to import it into Snap. And you want to click the button that says Upload My Model. Once you click it, it changes to uploading ... and then just update my cloud model. So you don't need to click it again once it's uploaded. Your shareable link will then have changed. And what you want is to copy that shareable link. So I just hit copy on that. And then if you go into our slideshow, or if you go to the presentation page on the SnapCon website, there's a Snap project there that you can open. So I'm going to open it myself here. Since I'm logged in, should log myself out so I'm not changing the default, or I'll just save mine. So you guys don't have to save yours yet, but I don't want to be overwriting the public project, so that's why I'm doing that. So that URL that you just copied, you'll want to go into the Snap project and change the text that says update with your URL and copy it in. And once you've done that, you'll want to hit the S key to load the, always do that. First, you'll want to turn on JavaScript extensions. Then you'll want to hit the S key. And what the S key does is it basically loads your model, the model that you just created. It doesn't start it yet, it doesn't start using it yet, but it loads it. So any questions there? I'll give people or I'll do it again, just for anybody who didn't catch it the first time around. So as I said, I went to my model. Click the button Export Model. And I didn't change any of the settings, but I did click the Upload My Model, which is in the same place as Update My Cloud Model is in this window. But if you haven't done it yet, it would say something like Upload My Model. And so I hit that button. And then once it was done uploading, I copied this link. And so I hit copy on that. And then I went and opened this project from the slides or from the Snap conference website. I opened it, and then I changed the URL to the URL I just copied. So I changed it to that, and then I hit S. I'm just going to leave this one and go back here. Okay, so that's how to kind of link the model that I just created in Teachable Machine into Snap. And then if I hit space, the first time it may take a minute, so it needs to be allowed to use my video, and I'm seeing that Snap doesn't want to, or it could be that it's confused because my Zoom camera is on, so I'm gonna turn off my Zoom. Stop and hit space again. Typically, it does take a minute the first time around. Actually, oh, okay. It's definitely allowed to access my camera. Let me save the project and then refresh, maybe. It's my URL now. So do it again. Oh no, I'm in the, okay. Let me open the project I had. So I'll hit S again, JavaScript extensions. Hit S again. Hit space again. Hopefully this time the camera picks up. Shoot. Okay, maybe I'll try my Chrome settings and select my other webcam. Just test that my webcam's working. Okay, good. It's working. Let me hit space again now. Okay. Yeah, there we go. So yeah, there can be a little, especially with Zoom running as well, and with two webcams, my setup is a little complicated in terms of which camera Snap has access to or wants to have access to. Now, I'll note this is an unresolved issue that I haven't figured out the reason for yet, but my webcam is only taking up a part of the canvas. And so a simple way to fix that is just to go to gear settings and stage size and change the stage size to 320 by 240, which is what my webcam is currently showing. I think I have to hit stop and space again. So, you know, there's a lot of data here. So there's the URL that's displaying, and then there's this prediction table and also the prediction list. So these are variables that this project contains, and the variable or the list prediction is actually what you can use in Snap to make your Snap programs react to the image model. Prediction table is just there to make a more user-friendly display of the different classes and their predictions. So if you remember in the image model, you know, here, like the output is giving me a % prediction of the thing that I'm showing it being, you know, the Hulk, or being something else that I programmed it for, right? So this prediction table is telling me the exact same thing, except instead of percentages, we're using decimals. So if I show it the pony, now the pony is 0.999999, and everything else is either 0 or, you know, Gremlin and nothing are bouncing around here with high numbers, but that's actually because if you zoomed out, which I can't do, they're using scientific notation. So this is like 6.0 times 10 to the -8 or something. So prediction table is just a kind of friendlier way to display the predictions. The prediction variable or prediction list is what you can use to use your, you know, to change your program. So in addition to this block, which when space is pressed, it starts predicting, which means it starts running the model, and it also activates the webcam. That's what the predict block does. I have a second piece here, which is kind of a starter program. So this when space key pressed, repeat until you hit X. If, you know, item 1 of prediction is greater than 0.9, switch my costume to Alonzo, otherwise switch it to Cat 3. So if I show it the Hulk, which is my first class, I get Alonzo, otherwise I get the cat. So there we go. We've got a snap program that basically is using a machine learning model we've created to do something. Now, this is very basic. You know, I'm sure many of you could come up with much more interesting snap programs to use this model as a sensor for. Like, you could make a game where you show different things and it, you know, it moves the sprites in interesting ways. So this is just one example, but the core of it is this kind of block here. You know, if, well, the if statement also, but the item 1 of prediction is greater than 0.9. What I'm saying there is, you know, if I'm 90% sure or more that I'm seeing the Hulk, change my costume to Alonzo, else, you know, change it to the cat. So you could obviously do multiple if statements, one for each class. You also don't need to use 0.99 or 0.9. You know, it depends on how good your model is and how happy you are with false positives, right? So you could set the threshold to 3 nines. I want to be 99.9% sure that I see the Hulk before I change. Well, in fact, this model does tend to be 99% sure in some situations, but it is glitching. You know, even when the Hulk is there, it's still glitching. So if I change it to 0.9 and I show it the Hulk from many different angles, now it stays, well, okay, maybe not like that. But for the most part, it stays Alonzo. It stays, you know, Alonzo more often. So it really depends on your own model and your own fine tuning where you might set that threshold of probability. Maybe you even do something where you use the prediction in some linear sense, right? Like maybe you set the costume size to the prediction. So the more certain it is, the bigger the object gets or something like that. So yeah, this is basically it. I'd love to, and I have less than 15 minutes left. So I think what I'll do is I'll continue the presentation because I just have a few more minutes to talk. And then anybody who wants to try this can stay in the room, and I'll be happy, Jen and I will be happy to help and troubleshoot. Or you can try it later with the model that you made. Either way is fine. So yeah, so basically these are just the instructions for using the model in Snap. Done this workshop several times and I've noticed some troubleshooting. So these are things that might help you. So, you know, we hit the JavaScript extensions thing because I never remember to hit that checkbox. The camera image thing we also hit. You saw like that in my case, I had to make it smaller in order to get it to, in order for the webcam image to take up the entire stage. What that really does, by the way, is if you leave the stage to the normal size and your webcam image is only taking part of it, it seems to make the model less accurate because it's now using all this white space and it's not sure what to do with it. You didn't train it on a bunch of white space. So I do recommend updating it if your webcam comes in too small. I've seen people copy the URL into the set URL box and add a space or somehow, you know, miss a semicolon or a slash or something like that. So just make sure that URL got copied properly. And I have seen sometimes the model just not wanting to refresh or update. There's basically, I haven't really figured out exactly the answer to this. I know there's a bug in our code somewhere. And what I recommend is just, you can export or save your project, close the window, close like the Snap tab, open a new Snap tab, and just open the project again. One thing that I found decent for general troubleshooting with Snap is, you know, if Chrome isn't working, try it on Edge if you're on Windows, because it doesn't seem to matter too much which browser you pick, but it somehow like, you know, it sort of resets things to use a different browser. So these are workarounds. They're not actual solutions, but they may work for you if you're running into problems. So that's basically it. I mean, in terms of diving deeper, into exactly how this works. I did link the teachable machine frequently asked questions. I really would like a better explanation of their lower level machine learning models, because obviously you're training a model to do object recognition very, very quickly. And the reason you can do that is because they've already built most of the object recognition model, and you're just training kind of the top layer. So it already has layers for recognizing colors and shapes and edges and things like that in objects. And I'm sure the same is true for audio and for their audio and their pose models. So yeah, I wanted to add, I found a few different AI resources and travels in the last few months. There's 5 free ISTE ebooks on hands-on AI. I thought that was really impressive. And there's like one for elementary educators, one for secondary, one for computer science teachers, one for, I think, after school specialists. So it's pretty cool. And then Halspeed put together this great presentation on physical computing and AI. So if you're really interested in doing AI with robots or other physical computing devices, he just listed a ton of resources, basically a lot of, one slide per kind of thing that's out there. And then I found some AI literacy units from MIT's RAISE project. So yeah, that's it. I'm happy to answer questions. Jen's happy to answer questions, or happy to give you 10 minutes to make a snap project as well. Part of the fun here too. Feel free to unmute or write in the chat. Either one's fine. See if I can turn my camera back on. Unplugging and plugging back in the camera seem to work. Yeah, Mark mentions that you can also train teachable machine on gestures. That's true. So like I said, image model is just one model. There's also the pose, and audio is really fun, especially with a robot, because you can say, stop, start, go left. Thanks, Victoria. Yeah, it's been fun to see it move forward. And like I said, I think you can learn a lot more from Ken's talk also, which I think is tomorrow. Let's see. Oh, Saturday. Yeah, Ken's talk is Saturday.
Yeah, very nice presentation. By the way, the Google team did write a paper about it in Kai. I'm going to put the URL in the chat right now.
Oh, thanks, Ken. Yeah. I'm hoping the relative silence is because people want to play with the snap projects that they are integrating the gene models into.
I think you just left everyone speechless. I encourage everyone to give the team a round of applause for the amazing presentation. A great way to start off SnapCon. So either virtual or turn on your camera and clap it up. That was really good. Thank you.
Thanks.
By the way, you maybe want to mention that besides using the webcam, you can bring in images as an alternative. Just
thank you.
drag and drop image files into
right.
digital.
Yeah, so you can upload samples as well as using the webcam. Yeah, that's right. I believe there are like public domain training data out there for different types of images, right?
Yeah, as a matter of fact, I had a student that actually was pre-med, and she found some chest x-rays with different kinds of diseases and was using Teachable Machine to see how well it could tell the difference between these different chest x-rays.
Wow, that's actually pretty incredible. Like, I mean, I know there's AI work on using it for chest x-rays and other x-rays, but the fact that Teachable Machine can distinguish, because this is sort of a toy machine learning model, you know, compared to
it is, but and obviously it wasn't, you know, ready for the clinic, but in terms of you know, a learning experience for a medical student, I think it was a very good one.
Yeah. Yeah, actually also a good example of how medical students need to be exposed to making these types of models or using these types of models, since they'll be using them probably, you know, for diagnosis pretty soon in their practice.
That's right.
Brian, I'll see you at 9. Is there a link to the vocabulary?
Sounds good.
Yeah. But would this work with a microcontroller or microblocks? So Victoria, it could work with a microcontroller. So we used it with robots, but we also have a way to control microbits standalone. So that would be from Snap. There is a Google Teachable Machine way of creating an embedded image model, and some people have been using that on, I'm not sure, maybe Raspberry Pis. Ken probably has a better sense of exactly how. And whether you can use it with microblocks specifically, I don't believe so at this moment. But I bet the audio, so there's some interesting work with microbits specifically, and using audio, using their microphone, and also doing models that are trained on gesture. And I would point you at this presentation, which I think was in my more resources. Yeah, like the physical computing and AI presentation that Hal created.
It's probably worth mentioning that, you know, that this in theory will run anywhere there's a modern browser. But a few years ago, I tried it with a Raspberry Pi, and it was very sluggish. But maybe the Raspberry Pi is faster, and maybe the software is improved. So it may well run at a decent speed now. But you do need a microcontroller that could run a web browser.
Yeah. But like when you go to new project in Teachable Machine, you know, you make a new image project, you can use a embedded image model. Oops, I want to show that option again. So, you know, you can export it to something that is more reasonable to run on a microcontroller. And then there is a hardware link there, so you can see where it would work. Yeah, so for microbits, again, for like, so there's 2 ways to run microbits. If they're controlled via Bluetooth over Snap, then this model would work directly with a microbit. But if you're trying to embed the model onto the microbit, you know, you don't have a camera, so that's an obvious issue. There is a little bit of work being done around using the accelerometer and training the data of like holding it in different, you know, getting it to basically detect more complicated gestures than just whether it's up or down or being shaken. And then there's a little bit of work around audio also. And I think, yeah, some of that is in here. Let's see, in Hal's talk. Once you get past that. Okay, so like there's ML machine for microbit v2. So that's one link. most of the standalone embedded uses for microbit really are just about training a model and don't seem to have much coding in them, I guess.
I'd
It
like
is
to take the
6:01.
time. Yeah, it
Yeah.
is. It is now
So-
time, and in around less than 15 minutes, you can go watch What's Cooking in Snap presented by Jens, who happens to be in our call right now. So you won't want to miss that either. So once again, a round of applause to everyone who presented. Did an amazing job. Good job to the team.
See everybody.